So if we increase the frequency of the compounding, that is, increase the number n, we will earn very little additional money off of this investment. The maximum one could possibly earn using the principal of 1,000 over 7 years with an interest of 3.1% is $1,242.34, which is only 1 cent more than if you compounded it daily. So there's not a whole lot of incentive to compound your interest more than daily. Like you could do it every hour, every minute, every second. And how often interest is compounded in real life kind of depends on the size of the institute. Like my bank compounds it every second, but then they've got some accounts with probably billions of dollars, and they have to get it right to the penny. My credit union, I have 2 different credit unions. One compounds weekly and one compounds monthly. So they deal with smaller amounts of money, and, it means maybe a penny here or a penny there, and nobody really cares about it. Or maybe it's still less than a penny because the amounts you're investing are smaller in a credit union. So this is a graph. The vertical axis is the amount of dollars that you earn, and this is given a principal of 1,000 times 7 years and a interest rate of 0.031 annual interest. And the horizontal axis is the value of n, the number of times per year that you're compounding the interest. And you'll see that what happens with the amount of money you make is it increases, but it approaches this asymptote. And that asymptote is the line A equals $1,242.34. And that's where I got that 1.4234. I know that's the asymptote there. Okay. Now you might wonder how I know that's the asymptote. Well, you could just keep making n larger and larger, and you'll see that it never gets above that. But I kind of took a shortcut. There's a formula for that asymptote. The equation for the asymptote in general is A equals P e to the RT, where E is a constant 2.7183. E is sometimes called the Euler number, E-U-L-E-R. It's a guy's name. Euler, also called Euler, depending on, it's German, so it depends on which German country you're in. If you ever say Euler and someone tells you you're wrong, you're not. Because it can be pronounced either way, which is strange, because in German, regular German, EU is a oi sound. Anyway, EU is a constant. Engineers use this constant E a lot, and in calculus we use it a lot. It's kind of like pi. It's a constant. It's a fixed number. It has the first few digits are there, 2.7183, et cetera, et cetera, et cetera, et cetera. Just like pi, it doesn't really repeat a distinct pattern at any point. It's an irrational number. So anyway, that's a constant E. And this A equals P e to the RT is actually a different kind of compound interest. It's what you get if you compound infinitely often. It's the asymptote of this little graph that I gave here. And every scientific calculator has a key E. On some of them it'll say E to the X, but if you wanted to get E out of it, you just do E to the 1. Not that hard. Some calculators actually have 2 buttons. One says E to the X and the other just says E. The e to the x key is almost always on the same button as the ln key. ln is natural log. That's the inverse of exponential function base e.